Richard James Mathematics Resources will now present Grade 4 Practice Paper 3, Part D. This D video will take us to the end of the practice paper that has 49 problems. But of course, the paper is divided into 4 parts. Each of the first 3 parts has 12 problems. This one will take us from, well, this does not have 12 problems. It will take us from problem number 37 to number 49. And do not forget that 48, 49, along with 47, so 47, 48, and 49, those problems are not multiple choice. So let us go with problem number 37, Jerry. Pay attention. A netball court has a rectangular area. Which of these shapes would look like a netball court?
Option B. Option B.
Okay, so that's option B. That is the one that is rectangular in shape or has a rectangular area. The correct answer is option B. So which of these is a rectangle? Option B is correct. There we have a rectangle. A rectangle has opposite sides that are equal and parallel. By now, we should identify the answer. As a matter of fact, Jerry Lewis identified the answer a long time ago. So we know a rectangle. It has 4 sides, of which opposite sides are equal and opposite sides are parallel. Not only that, but it has 4 right angles. Additionally, there are right angles at all of the vertices. So it has 4 right angles and the opposite sides are equal. Opposite sides are parallel. The illustrative rectangle was made in order that it might be a very close match to the one that we have in the option. So we did not just put our rectangle right here and hope that it would fit, but we put a rectangle that is sure to fit. Right onto it. So the illustrative rectangle is this one, and it is a rectangle with opposite sides equal in length and opposite sides equal in length. They are also parallel. These are also parallel. And additionally, a rectangle must have vertices that are accompanied by right angles. What is the size of a right angle, Jerry? The size of a right angle.
90 degrees.
What's that?
90 degrees.
Okay, 90 degrees. The right angle is 90 degrees. So there we have it. There we have a near perfect match. The one that was constructed on principle matches the one in the option. The correct answer is therefore option B. A square is also a rectangle. All of the features are the same. So all of the features of a square are the same as all of the features of a rectangle. But additionally, all sides of a square are
Equal.
equal. Which 2 shapes make up this diagram? What do you see, Jerry?
A circle and a rectangle.
A circle and a rectangle. So let us see which one has a circle and a rectangle. That one is sure to be the correct answer. Circle, rectangle. The correct answer is
Option C.
right. The correct answer is option C. The most blatantly incorrect options there are those that contain triangle. So they are incorrect. The one that we can see right away that they are incorrect are the options that contain triangle. That is a triangle. And a triangle has how many sides, Jerry?
3 sides.
Okay, 3 sides. So the triangle has 3 sides. A triangle is a polygon with 3 sides. In our diagram, there is no such shape. So in this diagram, no such shape. No shape that has 3 sides. Any option that contains triangle will have to go out. So any option that contains triangle, we will take those out. A circle is obviously there. Any option that does not contain circle has to go also. So a circle is right here. We cannot avoid this circle. It is very plain that we have a circle there. So if there's an option that does not contain circle, then that option is wrong. And what we have done, we have solved the problem by a process called elimination. So we have eliminated the answers or the options that are sure to be incorrect. So what we have left has to be the correct answer. And the correct answer, as stated by Jerry Lewis earlier on, is option C, that contains a circle and a rectangle. We have found our answer by elimination, and that answer is option C. And we have our illustrative rectangle going right onto it, right there. If the shape were a square, we could still say circle and rectangle. Why is that? Because a square is a square is also what, Jerry? A square is also a rectangle. Right. The options may not have square, and we may use context clues. So if we had a square inside there, and we did not have the word square in any of the options, but we have rectangle, then we could use rectangle, because a square is a rectangle. If n minus 6 is equal to 12, what is n? You have a number, Jerry. When you take away 6 from that number, the number is 12. What number is that?
18.
How did you get that?
Because you add 12 plus 6, and that gives you 18.
Well, Jerry, we will have to explain how you just say 12 plus 6 is equal to 18, and we are sure that the correct answer is option A. But let us see if there is any additional explanation or useful explanation or fundamental principle that we need to adhere to in arriving at our answer. What we have there is an algebraic expression. It is an algebraic expression because it has numbers and symbols. The type of algebraic expression is an equation. The two identifying marks are A, the equal sign. So if we have an equation, there has to be an equal sign, right? And in an equation, we also need to have what, Jerry?
Unknown.
We need to have an unknown that we need to find. So that is the two most significant identifying marks of an equation. It has an equal sign, and there is an unknown of which we are required to find its value. By common sense, there is a number that we subtract 6 from. If we subtract the number 6 from that number, say we have a number, Jerry, and we subtract 6 from that number, did the number get smaller or larger?
Smaller.
Right. Therefore, the number that we subtracted 6 from, for this number here we have, is 12. When we subtract 6, the answer is 12. Is that number going to be less than 12 or more than 12?
More than 12.
Okay, good. It has to be greater than 12. So by common sense, there's a number that we subtract 6 from, and the answer is equal to 12. If we reduce the number and it is equal to 12, then it must be greater than 12. The number had to be greater than 12 in the beginning. Is that right, Jerry?
Yes.
Okay. So n is equal to 12 plus 6. And that gives us 18. And that is represented by option A. For greater than 12, we need to add 6. We add 6 to 12 and we get 18. Common sense is greater than mathematics. If humanity had another way of administering a common sense examination, then there would have been absolutely no need for mathematics. The number was reduced. We have to increase. The correct answer is option A, as we discussed before. Addition is not the only process that will increase the number, but we need to do the opposite of subtraction, and the opposite of subtraction is
Plus.
right. So the opposite of subtraction is addition. N minus 6 is equal to 12. The equation that we have has negative 6 accompanying the unknown on the left-hand side. In solving the equation, the unknown must be the only thing on the left-hand side. So we have n minus 6 is equal to 12. Now, we need to find n. If we are going to find n, when we are through, n has to be the only thing on that left-hand side. But what? It is accompanied by negative 6 on that left-hand side. What do we need to do? Jerry is saying that we need to put down another 6. That's correct. But we may not just put it down. We have to know exactly how to put it down. Right. So we need to... Okay. Right. Well, I hope that Jerry is not using the previous solution as the gateway to this particular one. It might be used, but we are taking a different approach on this occasion. We are going to strict mathematics principles. So the negative 6 is on our, we have take away 6 there. So the n is there and we have take away 6. We need to remove this 6 that we are subtracting or eliminate it. We need to eliminate the negative 6 from the left hand side. In mathematics, we eliminate something by doing the opposite. And what is the opposite?
Plus.
Right, plus. The opposite of minus is plus. The opposite of addition is
Minus.
right, or subtraction. The opposite of subtraction is addition. Negative 6 and positive 6, or take away 6 and add 6, or we may say subtract 6 and add 6 are additive inverses. They will cancel each other. So if we have a minus 6 and we have a plus 6, because they are equal in size, this is a 6 and this is a 6, but the signs are different, we say that they are additive inverses. So if we have two numbers that are of the same size and the signs are different, like an addition and a subtraction, we say that they are additive inverses. When we add them, they will have a cancelling effect on each other. Therefore, when we add together numbers that are additive inverses, the result is 0. If we add 0 to 5, what do we get, Jerry?
5.
Right. So any number we add 0 to, we'll get that same number. So if we can use the additive inverses, then we will eliminate the negative 6 from that left-hand side. So the opposite of subtraction is addition. Add 6 on the left-hand side. Negative 6 and positive 6 are additive inverses. They will cancel each other. So we add 6 on that left-hand side. However, the equal sign testifies that both must be equal, that both sides must be equal. So where we see this equal sign, the left-hand side has to be equal all the time to the right-hand side. Therefore, in the beginning, we did not have a plus 6 here, but we added 6 here in order to eliminate this negative 6, because they are opposite, so they will have a cancelling effect on each other. However, the equal sign testifies that both must be equal. Both sides must be equal. They must be balanced. If we do something to one side only, it will be unbalanced. We need to add 6 to the other side also. So we cannot just have an equation and then all of a sudden we just add 6 to one side. That is not fair. That will not cause it to be balanced. In order for it to be balanced, we need to do what? Add 6 to the other side also. What happens? Let me see if we have a caption for it. No, we do not, but I'll explain it to you. When we add the 6 here, it causes a cancelling effect on the negative 6 or minus 6. So when we have negative 6 plus 6, the result is what, Jerry?
0.
The result is 0. So when we have n plus 0, what is that equal to, Jerry? N plus 0, what is it equal to, Jerry?
N plus 0 is equal to n.
Right. N plus 0 is equal to n. Any number we add 0 to will result in that same number. So actually, minus 6 plus 6, that's 0. 0 added to this n will just be n. But do not forget that when we added the 6 to the left-hand side, we had to add 6 to the right-hand side also. Right. So we will have the 6's or the additive inverses eliminating each other on that side. But on the right-hand side, we need to have what? 12 plus 6. We need to complete the addition process. And n is equal to?
18.
And that is represented by option
A.
The correct answer is option A. So there we have our what we call intermediate step. In a written examination, students usually leave out any intermediate step because they will not lose marks for doing so. So if we leave out an intermediate step that is not necessary, we will not lose marks for leaving out that step. The 6, which is accompanying the unknown, is related to it by subtraction. Right. We need to eliminate it by doing the opposite of subtraction, which is
Addition.
we will do the same to the other side. As a result, 6 is eliminated from the left-hand side, but we still need to add it on the right-hand side. So, because, let's see if we can, right, because we need to eliminate this minus 6, we plus 6. We cannot do it to one side, we do it to the other side. So what do we have?
Minus
6 plus 6, 12 plus 6. So we have 6 added to both sides. As a consequence of that, the negative 6 plus 6 will have a cancelling effect on each other. And what will happen? We will end up with just n on the left hand side, but we need to complete the addition process on the right hand side. What students do is they leave this step out. So because n minus 6 is equal to 12, they say that n is equal to 12 plus 6, and they have a lot of incorrect ways of saying it. One way of saying it is the 6 that we have on the left hand side, it goes over the equal sign and its change is to positive or plus. That's not correct. So it is not a 6 that we have here that goes over the equal sign. It does not go over the equal sign. And some will say that the negative 6 that we have here is added on the right hand side. That's not correct. The 6 which is accompanying the unknown is related to it by subtraction. We need to eliminate it by doing the opposite of subtraction, which is addition. We will do the same to the other side. As a result, 6 is eliminated from the left hand side, but we still need to add it on the right hand side. Or, because we have added it to the right hand side already, we still need to complete the addition process on the right hand side. But what do? Sometimes we leave out that intermediate step. That's what we do sometimes. And this is what we say. Because of this, students are tempted to say that the 6 that was subtracted from the left hand side, which is this 6, was subtracted from the left hand side, is then added to the right hand side, which is not correct. The fact is, it was added to both sides, right? It was added to both sides, which caused it to be eliminated from the left hand side. But we need to complete the addition process on the right hand side. In this case, we have a number p. So we have another equation. If p multiplied by 5 is equal to 25, what is p? So here's your question, Jerry. Let me see if I can take this off. If we have a number and we multiply that number by 5, the result is 25. Is this number larger or smaller than 25?
Smaller.
Jerry is saying that it has to be smaller. That is correct. Because if we multiply something by another number and we get a particular number, then whatever we have as the answer, then the first number should be less. As a result, how do we get less in mathematics, Jerry? How do we get less in mathematics, Jerry? There are two ways.
Dividing or subtracting.
Right, so we do that by dividing or subtracting. Which one do we do in this case?
Divide.
We divide. Why do we divide? Because it is the
Opposite
of
multiplication.
right. So because it is the opposite of multiplication, we will divide. So let us see what is in store for us on that slide. So if p multiplied by 5 is equal to 25, what is p? In this case, we have a number p multiplied by 5 and the result is 25. What number do we multiply by 5 and the result is 25?
5.
Jerry is saying that it is 5. Of course, because Jerry is sharp on his multiplication table. 5 5s
25.
is as easy as that. If we consult our multiplication table, then the answer will be here in a few seconds. And they will go away in a few seconds also, Jerry, because I am not spoiling my students by causing the multiplication table to remain on the slide for too long, because you should really know your multiplication table. So the number that we multiplied by 5 and the result is 25 is 5. So P is equal to?
25.
P is equal to?
5.
Right. So we have a number here to be multiplied by 5. The result is 25. What number do we put here so that the result is 25? Jerry is saying that that number is 5. Therefore, the correct answer is 5. And that is represented by?
Option A.
That is how fast the answer is forthcoming if we are prepared to use our basic knowledge along with our common sense. The correct answer is option A. Common sense is greater than mathematics, and it is better to be adept at reasoning and thinking than to be able to manipulate a lot of mathematical devices without the full understanding of them. What did I say? Common sense is greater than?
Mathematics.
Right, and it is better for us to reason and think than to be able to manipulate a lot of mathematical devices without the full understanding of them. In the equation, 5 is accompanying the unknown on the left-hand side. In solving the equation, the unknown must be the only thing on that left-hand side, which means that we need to eliminate the 5 that we have on that left-hand side accompanying the unknown, which is P. The unknown is multiplied by 5. So we have P is the unknown and it is being multiplied by 5. We need to eliminate 5 by doing the opposite of multiplication. And what is the opposite of multiplication, Jerry?
Division.
Right, division. That means we need to eliminate the 5 by division. So we have the 5 right there accompanying the unknown by multiplication. We need to eliminate that 5 by doing the opposite of multiplication, which is division. We cannot divide by 5 on one side. We have an equation. The equal sign means that the values on both sides are equal. For them to remain equal, what we do to one side, we will have to do it to the other side also. So we will eliminate P is the only thing that should be on that left-hand side. We need to therefore eliminate the 5 that we have multiplying. In order to eliminate that 5, we need to do the opposite of multiplication, which is what, Jerry?
Division.
So we need to divide. But we cannot divide on one side only. We have to divide on both sides. So we divide by 5 on both sides. What happens there? The 5s that we have there will cancel each other. So the 5s on the left-hand side will be eliminated. And we need to complete the division process on the right-hand side. So we have 25 divided by 5, and the result is 5. So when we divide by 5 on this left-hand side, the 5 is eliminated. When we divide by the 5 on the right-hand side, we have to say 25 divided by 5. But we have to divide by 5 on both sides. What we do to one side, we will have to do to the other. The correct answer is therefore option
A.
John has M pencils. He gives 3 away, which represents the number of pencils he has left. So he gives 3 of them away. John has M pencils. He gives 3 away, which represents the number of pencils he has left. What option, Jerry, if he gives 3 away?
B.
B. He has M. He gives away 3. M. minus 3. And that option is B. B is the correct option. So there we have the M pencils. There is the number of pencils that John had at the beginning. He gives 3 away. If he gives away 3 of them, then the number of pencils will decrease, which is correct. M minus 3 or 3 minus M. We have 3 minus M right there. But Jerry says it is M minus 3, and he is correct. It is the number of pencils M that we are decreasing. It therefore has to be M minus 3. We are reducing M by 3. So that's M minus 3. The correct answer is option B. Candidates should learn not to be distracted by illogical answers. Maybe if 3 minus M were not there, it wouldn't have been given consideration. So we have option C, which is 3 minus M. If it were not among the options, maybe it would not have been given any consideration at all. Students did not need to give consideration to 3 minus M, because starting with M and giving away 3 is simply M minus 3. And we'll try to see that on a next slide. No, we have a different problem to solve, Jerry. If Q plus 4 is equal to 12, what is Q? Now, if we have a number, Jerry, and we add 4 to it, and the result is 12. We add 4 to that number, and the result is 12. Is that number greater than or less than 12?
Greater than. Less than 12.
Right. So it must be a smaller number that we add 4 to, and the result is 12.
Yes.
Right.
8.
And Jerry is saying that that number is
8.
Is 8. Right. I like when students are quick on their arithmetic, and Jerry is very quick on his arithmetic. What we have there is an equation that we need to solve for Q. We will first take a common sense approach in solving that problem. So we are solving a problem for, what is that unknown, Jerry?
Q.
Right. So let us proceed to solve that equation for that unknown, which is Q. What we have there is an equation that we need to solve for Q. We will first take a common sense approach in solving it, and we discussed that with Jerry just now. When we add 2 numbers, the result must be larger than the 2 of them. 12 must be larger than Q, and 12 must also be larger than 4. So any number that we find for our answer, it has to be smaller than 12. Since 12 is the largest, whatever we do in finding Q, Q must be smaller than 12. By common sense, subtract 4 from 12. Q is equal to 12 minus 4. And as Jerry stated, that 12 minus 4 is equal to
8.
Right. How many circles do we have there, Jerry?
12.
I don't think you counted them, Jerry. I think that you are just making use of the fact that I will put the numbers on. And because we had 12 pencils to begin with, you are just saying that it is 12. And what do? We will subtract 4. We will subtract 4. How many remains? Well, we can see that all we have right there is 8. So 12 minus 4, and the result is 8. And that is represented by which option, Jerry?
B.
It's represented by option B. If we look at the equation and ask the question, what do we add 4 to, and the result is 12? Then the answer that we get must be less than 12. Subtraction is therefore Correct. What is it that we add 4 to and the result is 12? What number do we add 4 to and the result is 12? Then the answer that we get must be less than 12. Subtraction is correct. In the equation, the unknown is on the left-hand side, accompanied by plus 4. So we will be sticking strictly to principle on this occasion. In solving the equation, the unknown is required to be the only thing on that left-hand side. How do we remove 4 from that left-hand side? By subtracting 4. Why do we subtract 4? Because we are adding 4. The opposite of addition is subtraction. And we need to do what it takes to eliminate that 4 that we have there that is accompanying Q. And it is accompanying Q by addition. Therefore, we will eliminate that 4 by
subtraction.
Right, by subtraction. If we minus 4 from the left-hand side, then 4 minus 4 is equal to 0. And the 4 will be eliminated. So if we put a minus 4 right there, we will have plus 4 minus 4, and the result will turn out to be 0. What about 0 plus Q? What is that equal to?
Q.
Right, that's equal to Q. So since the expression is an equation, it means that both sides are equal. By subtracting 4 from one side, the equation is unbalanced. We therefore have to subtract 4 from the other side in order to keep it balanced. So we have 4 that we need to eliminate from that left-hand side, and we do that by subtraction. But we cannot do that on one side only. So we have to subtract 4 from the other side. As a result, 4 will be eliminated from the left-hand side, but we still need to complete the subtraction process on the right-hand side. So 4 minus 4 is equal to 0. And if we add 0 to any number, then the result will be that same number. So Q is equal to 12 minus 4. We need to complete the subtraction process on that right-hand side. Q is equal to 8. The correct answer is option
B.
Q plus 4 is equal to 12. And we are taking out that intermediate step that you know already. Okay? The intermediate step. Right. So we need to eliminate that intermediate step. We do not have to eliminate that intermediate step, but generally, you know, by the time you are in grades 9, 10, 11, 12, 13 in high school, you will be eliminating or omitting a lot of unnecessary steps. And the intermediate step in which we subtract, in this particular case, 4 from both sides, that is the one that you might want to neglect. Not neglect, but not to include. In a written examination, students do not lose marks for leaving out unnecessary steps, like the intermediate step in solving an equation. If we have Q and 4 is added to it on that left-hand side, then what do? We eliminate the 4 by subtraction. And we need to also subtract 4 from the other side. As a consequence, The 4 will be eliminated from the left-hand side, and we need to complete the subtraction process on the right-hand side. So the 4 which accompanies the unknown is related to the unknown by addition. We need to eliminate it by doing the opposite, which is subtraction. We will do the same on the other side. As a result, 4 is eliminated from that left-hand side, but we still need to subtract it from that right-hand side. However, the intermediate step that we have there is sometimes eliminated, and we are tempted to say things that are incorrect. Notice that what we have there is actually that we are subtracting 4 from both sides, and that is what we need to do, and that is what we did. However, this is what happens sometimes. Because of this, students are tempted to say that the 4 that was added to the left-hand side is now subtracted from the right-hand side, which is not correct. The fact is, it was subtracted from
both sides.
It was subtracted from both sides, which caused it to be eliminated from the left-hand side, but we need to complete the subtraction process on the right-hand side. John gets $D each day for how many days, Jerry?
5.
If you are going to school, how many school days are in the week, Jerry?
5.
Right. Which shows how much money he gets for the 5 days. John gets $D each day for 5 school days, which shows how much money he gets for the 5 days. Want to take a go at that, Jerry?
Yes.
What is the answer?
So it's 5 times S dollars.
Right. Right. So it's going to be 5 times the amount of money that he got. And that is represented by which option?
Option D.
Right. However, we see the word per or each. Whenever we see the word per or each in mathematics, it is usually a clue that we need to divide. But this is when we want to find the amount of each. On this occasion, we do not want to find each. We want to find the overall amount. Do not forget, in mathematics generally, when we see per or each, we are thinking that what we need to do is divide. But we should only divide when we need to find the amount of each. On this occasion, we are not finding the amount of each. We are finding how much money he gets for the total of 5 days overall, which is not each, but the total sum. So we do not imagine on this occasion that we should divide. For the 5 days. In this case, we are not finding the amount of each, but the amount overall. We therefore do the opposite of division, which is multiplication. The correct answer is therefore option D. But you said that earlier on, Jerry. So we are sure that it is option D. If we need the amount for all of the days, there is no way that it can be smaller than the number of days. It has to be more. Why multiply instead of add? So if we have the amount for 1 day, then we have the amount for 5 days. Will the amount for 5 days be smaller or larger than the amount for 1 day? It has to be larger. Therefore, we need to multiply, as you said, Jerry. But why do we multiply instead of add? Because D is the amount of money and 5 is the number of days. It is not practical to add money and days. Also, it is out of character with the nature of the problem. We have the same problem there. Be practical. There are 5 school days in a week. How many school days do we have in a week, Jerry?
5.
What are they?
Monday, Tuesday, Wednesday, Thursday, Friday.
Right. Let us say that John eats 2 chairs each day. John eats how many chairs? 2 chairs each day. 2 chairs on every day. How many chairs did he eat overall?
10.
We may count them. And we will get 10 chairs overall. So we are taking a look, making use of a practical situation in order to justify our answer and to come to a conclusion if we should have any problem that is similar to this one. So we are making the judgment for similar problems. And we are also proving that multiplication is the right thing. But by so doing, we make use of chairs, the number of chairs eaten each day, and the number of days in a week. And if we eat 2 each day for 5 days, we end up with 10 chairs. And we will say, how did we arrive at 10 chairs if we have 2 and 5 as the operands? What is the operator? The operands are 2 and 5. Which operator will give us a result of 10? 2 5s.
10.
2 plus 5.
7.
Right. So if we add, we would get 7. But in order to get 10, we had to multiply. Therefore, multiplication is the correct thing that we should do if we have a certain amount occurring for 5 days and we need to find the total overall. Students may glance at the word each and immediately divide. However, students need to take a good look at the problem in order to determine exactly what is required. So, not because you see each, Jerry, it means that you are going to multiply. Or it means that you are going to divide. Right. You need to look what is required. If the amount of each is required, that is when you divide. But if the overall amount is required, we
multiply.
Before we solve the other problem, there are some things that we need to pay attention to. The less than sign and the greater than sign. Why they are written in the way that they are, and what is the meaning of each sign. So let's go. Which sign do we have there, Jerry?
Greater than.
So the sign that we have there is the greater than sign. We use it to tell when we intend to say that one number or expression or object is greater than the other. We use it when we need to say that something is greater than something else. Greater than. Because 20 is greater than 13, we write it this way. 20 is greater than 13. That sign may be used to give the relative size of anything that we want to say. Let us say that x is greater than y plus 5. X is greater than y plus 5. That one is your less than sign. We use it to tell when one number or expression is less than the other. 7 is less than 15, so we write it this way. 7 is less than 15. If we intend to say that 2a is less than 3b, we write it like this. 2a is less than 3b. This sign is the less than sign, and this one is the
Greater than.
okay. There are two easy signs to remember, but students often confuse them. Teachers supply many methods for you to remember them, but consider the real reasons for writing them that way, and it will help you to remember them. We are going to consider the real reason for writing the signs that way. The one that goes in the direction of the increasing numbers on the number line is greater than, Jerry. So there we have our number line. Your number line is one that continues indefinitely in both directions. The arrows are at both ends, and they mean that the line will continue forever. When we place numbers on a number line, we are only presenting a small section of the line. So what we have there is not the entire number line, but a small section of the number line. And the arrows will tell us that the number line will continue and continue on and on and on without stopping in the directions of the arrows. So we are supplying numbers for our number line. And the number line has numbers going from 3 to 8. And when we are presenting a number line, we are not presenting the entire number line, but just a small portion of it, like we are doing right there. Numbers increase to the right and decrease to the left as indicated by the arrows. So if we continue here, what number will come in this direction, Jerry?
9.
Then
10.
and
11.
right. And if we go in this direction, what number do we have?
2. 1. 0.
Right. So the arrows show that the line continues in this direction and in this direction indefinitely. Also, when we go here, we are going 8, 9, 10, and so on. When we go in this direction, we are going 3, 2, 1, 0. So numbers increase to the right and decrease to the left, as indicated by the arrows. It is easy to remember the arrows on the number line. So it is easy to remember your greater than and less than signs. So there we have our greater than sign and our less than sign. The greater than sign is in the direction of increasing numbers. The numbers are getting greater each time in that direction. The less than sign, the numbers are getting less in that direction on the number line. Number line, that's your number line, and we are throwing in a few numbers, and we are also throwing in your less than sign and your greater than sign. The greater than sign is the one that goes in the direction in which the numbers increase on the number line. So the greater than sign, notice the numbers are getting larger here. And what do we have? The greater than sign, because when we continue like that, the numbers getting greater or larger. That is the direction, and this greater than sign is in harmony with that arrow. The less than sign is the one that goes in the direction in which the numbers decrease on the number line. Less than sign, decreasing, getting smaller each time. Those numbers in this direction getting smaller each time, so the numbers are getting less. So that's the less than sign, the arrow that is getting less each time. In remembering the signs, some teachers tell students to put their arms akimbo. Their two arms will form the less than and greater than signs. Left is less and right is greater. That is how some teachers say it. However, I encourage you to remember the number line and the arrows that tells that the numbers go indefinitely in both directions. The direction in which the numbers get larger is your greater than, and the direction in which they get smaller is your less than. Which statement is true? And I am not going to say what these are. True. The emphasis is on the word true. Now we will use one stone and kill two birds. We will answer the question while engaging in activity used for sharpening our memory of the greater than and the less than sign. So we are attempting to achieve two things right here. One, we are solving the problem, and two, we are going to be looking at some activities that will help us to remember the less than and greater than signs. So what we have there are the numbers in the option. Notice that we have the same numbers here like in the option. Place one of the signs greater than or less than between each of the pairs of numbers. So we are going to say greater than or less than. We are going to put that sign between the pairs of numbers. So what do we say about this one? 16 what? 4.
Greater than 4.
16 is greater than 4. 16 is greater than 4. What sign do we use when 16 comes before 4? 16 is greater than 4. The greater than sign is correct. 16 is greater than 4. And what do we imagine in this case? The exact same thing. 16 is greater than 4. What about that one? What sign do we use when 4 comes before 12?
Less than.
Jerry is saying less than. That's correct, Jerry. 4 is less than 12. 4 is less than 12. The less than sign is appropriate. 4 is less than 12. And if 4 is less than 12, then 12 is greater than 4. 12 is greater than 4. So Jerry is practicing his left arm and right arm greater than and less than signs instead of remembering the number line. The activities were created from the options which one matches. So we are looking and see which one matches what we have there. Let's see. Let us compare those two. Is that right?
Yes.
Is that right, Jerry?
No, the signs are different.
The signs are different. Therefore, option A is not correct. What about option B?
Yes.
Are they the same?
Yes.
So that one is true. Option B is correct. What about that one? Are the signs the same?
No, it's less than.
So those are different. What about the final one? Are those the same?
No.
Okay. So those are also incorrect. So the only one that is correct is which one?
Option B.
Right. The one that matches is option B. So option B is correct. Let us take a look again. Option B. 16 is greater than 4. Which is true? 16 is greater than 4. So that's right. If 18 something with 3 and the result is equal to 6, which sign does the little rectangle represent? And Jerry is saying it is division. Let's see. Why do we highlight those two signs? Because those two signs will cause the number to increase. The first two operators, A, multiplication, and B, division, will serve to increase the value of 18 when 3 is used as the other operand. So, 18 times 3 will be greater than 18. But we have 6. That's not correct. 18 plus 3 will be greater than 18. But we have 6, which is less than 18. So we are sure that these two signs cannot possibly be correct. However, the result that we have is smaller than 18. For a smaller number, it cannot be that we added 3 or multiplied by 3. The correct operand must be one of the others. The correct operation must be one of the others. If we subtract 3 from 18, then the result cannot possibly be 6. If we subtract 3 from 18, then the result cannot possibly be 6. Division must be the answer, and option D is correct. So there is a figment of your 6 times table, and we are not going to put it there forever. It's going to disappear in a few seconds. 6 3 is 18. We just saw the shadow of our 6 times table. 6 multiplied by 3 is equal to 18. No doubt, if we turn it around, 18 divided by 6 is equal to
3.
And 18 divided by 3 is equal to
6.
This will confirm that the answer should be achieved by division, and that also confirms that our answer is option D. So let us see. If we use addition and multiplication, the result is going to be larger than 18. Those two are not correct. 18 minus 3, is that equal to 6?
No.
So that's not correct. So the other answer has to be the correct answer. And we know that 18 divided by 3 is equal to 6. Because if we know our multiplication table, 3 6 is 18. So we may use the reverse of our multiplication table when we are dividing. And we will be sure to get our correct answer. The table shows the favorite sports of some boys. Which two sports do 17 children like? Which two sports do 17 children like? Now, it is easy to tell which two sports 17 children like.
Football and basketball.
But we did not need to count them because they are the only two sports with equal numbers. Right? And we did not even have to count them. but we can use the length of the row to tell that they are of equal numbers because the rows are of equal length. And that we should be able to do as long as the tally chart is properly organized. There is one of our bunch or tie. When tallying data, the diagonal stroke is also counted. Each group with a diagonal stroke is 5. When counting tally items, count by groups of 5, then add the extras. So, when we are counting, we do not count these because we know that the number of them is equal to 5. There's always 5 of them when we have the diagonal stroke. So what do we say? If we are counting the first, we say 5, 10, and we have 2 more. 12. Right. And if we are counting basketball, we say what? 5, 10, 15, and we count 2 more. That's how we do it. So the first one is 5, 10 plus 2, and that is equal to 12. And the other one is going to be 5, 10, 15 plus 2, and that will give us 17. Then we say 5 and an extra 1, and that will give us 6. And then we say 5, 10, 15, and the extra 2 will give us 17. The sports that 17 children like are basketball and football, and are represented by option B, because we have 17. And as we said before, we did not even need to count them because they are the only 2 sports with equal numbers. And we know that because the table is properly organized, and we can look at the length of the rows and we can see those that are equal quite easily. No other 2 sports have the same number. As long as we can find the 2 equal sports, we would have our answer, and we might have been able to do that without counting. So no 2 sports have the same number. No other sports have the same number. As long as we can find the 2 equal sports, we could have our answer, and we might have been able to do it without counting. The table shows the lunch menu at a school canteen. A student buys 1 chicken lunch and a drink. How much change will the student get from $200? How much change will the student get from $200? 1 chicken lunch and a drink. So the operative thing is how much change. We need to find the change. But before we can do that, we need to find the total cost of the lunch. We have to find the total cost of the lunch first. Write down the cost of the chicken lunch, which is what? $90. And Jerry is saying that the result when we add them should be $135. That's nice, Jerry. I think that you are correct. Also, write down the cost of the drink. Write that down. And in order to find the total cost, what do we do, Jerry? Add. Let us go ahead and find the total cost. This is not very difficult to add, Jerry, because we have a lot of zeros there. We will begin at the right. All that we have there is the sum of those zeros. Nothing else but the sum of those zeros. That will give 0. Vertically align the points. There we go. points below point. And 5 plus 0, what's that equal to?
5.
And 9 plus 4 is equal to?
13.
That's all there is to it. So 9 plus 4 is equal to 13. And the total turns out to be?
$135.
But we cannot do that without the dollar sign. So we may now include the dollar sign. On the next slide, we will find the change from the what? $200. We'll do that by subtracting our total from $200. And Jerry is saying that it is?
$65.
So Jerry would have made that calculation already. Jerry is no midget with digit. All that we are doing there is subtracting 0 from 0. Right there. All that we are doing there is 0 from 0, so we know that's 0. Vertically align the points. Whenever we have a problem that involves a decimal fraction, the points have to be vertically aligned. We cannot take 5 from 0. Go to the greater place value. There is a 0 there. Go even higher and rename the 2. So when we say 5 from 0, can we do that?
No.
We need to go here to rename. When we get there, what do we find?
Another 0.
Another 0. So we will go all the way to?
2.
And there is where we start to rename. And remember now that after renaming the 2, the value has to be transferred all the way down to the?
0.
Down to?
5.
Right, all the way down to the 5 that we are subtracting. The 1 taken from 2 will be 10 times the digit of less significance. So when we are here, if we take out a 1, if we place it here, it will be what? 10 times the digit of less significance. For example, the 2 that we have here is 100. That's right?
Yes.
When we put it in the tens, 100 is equal to 10 tens. Right. So, because 1 is what we are taking from this, and it is going to be 100. So we are taking 1 from the hundreds, and we are bringing it down to the tens. So it is going to be 10 tens. And there is our 10 written with this 1 that we bring from here and the 0. So we are just writing that in a short or a very minute and convenient way to write the 10. And then what do we do with the 10? We take 1 from that 10 and it is going to be, we are going to be left with 9. And the 1 that we take here is what? 10 times the digit of less significance. Right, so we have a 10 there. So we say 5 from 10 and the result is?
5.
Then we say 9, take away 3 and the result is?
6.
And then we say what? 1 take away 1 and the result is?
0.
0. Do we need to put a 0 here?
No.
1 minus 1 is equal to 0. A leading 0 does not contribute to the value of the number. So we may not include it. We do not have to include that leading 0. We need to include the dollar sign though, because we are dealing in currency. So the dollar sign has to be included. Do not forget that it depends on the way that we look at it. If we are here, the digit to the left is what? 10 times the present place value. And if we are here, then this digit is 10 times the digit of less significance, the one that is located to the right. So when we are here at a particular position, anywhere we are, then the digit to the left is what? 10 times the present place value. And if we are right here or anywhere we are, this digit is 10 times the digit to the right, which is the digit of less significance. The change that the student gets from $200 is actually
$65.
and it is not located in any option because this problem is not a multiple choice problem. Number 48. A farmer has 24 animals. There are 3 goats. We know that the number of goats is 3. The other animals are cows, chickens, and pigs. The pie chart shows the fractions which represent these animals. Which animal is the largest group? Jerry, you can see the pie chart. Which one of those divisions is the largest? It is the biggest one of all of the 4 of them.
Pigs.
Pigs is the largest. As we can see, the largest portion, sector, is the one allocated to the pigs. That's the one that is the largest. The group of pigs is therefore the largest group. Pigs represent the largest group. The farmer exchanges 6 of his pigs for 6 chickens. The table shows the number of animals that the farmer now has. Complete the table by writing the name of the animal that correctly matches the number of animals. So, we have 312, 36. But the numbers that we have here, not the original numbers. These are the numbers after the farmer exchanges 6 of his pigs for 6 chickens. So, these are the numbers that we have after the exchange. And we need to complete the table. So what do we do? To find the number of each animal that he now has, it is good if we know the numbers that he had at the beginning. So we have not seen the numbers that he had to begin with. So we'll have to find the numbers that he had to begin with. Then, when we do the exchange, we will find the new set of numbers. Correct, Jerry?
Yes.
So we should go ahead and see how many of each animal the farmer had to begin with. So let us try to find that out. There are how many goats?
3.
3 goats. Any section looks the same size as goats?
Yes.
Which one? Cows. Okay. So we have 3 goats. The sectors for cows and goats are the same size. They are equal numbers. I am saying that the sector for goats and cows, these are the same size. So I'm saying if this is 3, then this has to be
3.
right. But what we do is match them. So we match them. Let's go back. Do we have a perfect match, Jerry?
Yes.
We have a perfect match. What does that tell us? It tells us that we also have 3 cows. That the number of cows and the number of goats are equal. So 3 cows and 3 goats. The sector for chicken is the same size as the sectors for goats and cows together. Notice that what we have there, if we see them going away, is that we have a quarter of the entire pie right here. And what size do we have here, Jerry?
Quarter.
A quarter. Right, Jerry is saying a quarter for the chickens. That's correct. So if this represents a quarter of the pie, and how many animals in all do we have?
6.
Therefore, how many animals do we have in all here?
6.
Right, so we have 6 here in total here, and we will have 6 here. Why? Because this size and this are the same. So the sector for chicken is the same size as the sectors for goats and cows together. The number is therefore 3 plus 3, which is equal to
6.
6 chickens. That's it. No, that's not it. A farmer has how many animals?
24.
24 animals. In finding the number of pigs, we may do it 2 ways. 1, make use of the fact that there are how many animals in all?
24.
Right. And the size of the sector for pigs is half of the entire pie. Can you see that?
Yes.
The sector for pig is half of the entire pie. It is half of the entire thing. And what is the total number?
24.
What is the half of 24?
12.
Right. So in order to determine the number of pigs, we say 24 divided by 2, and the result is
12.
And that's the number of pigs that we had to begin with. We may also do it this way. The size sector for pigs is equal to the other 3 animals together. Is it true that when we put all these together, it is the same size as over here?
Yes.
Right. So because all these together is the same as this, so when we add all of these, we will get this. So 3 plus 3 plus 6. 3 plus 3 plus 6. And the result is
12.
12. So we are sure. Anyhow we look at it, to begin with, we have how many pigs?
12.
12. We have all of the original numbers. Let's exchange. So we have all of the original numbers. That's what we wanted, Jerry.
Yes.
We want to know, the problem says, after the exchange, we need the numbers. Is that correct?
Yes.
But we need to have the numbers before the exchange, and then that will make our lives easier. The farmer exchanges 6 of his pigs for 6 chickens. Look again and see what? 6 of his pigs for how many? Of which one?
6 chickens.
Right, 6 chickens. So that's the exchange. So we will go through the exchange on this slide. The farmer exchanges 6 of his pigs for 6 chickens. During the exchange, the farmer will give away 6 of his pigs. If he had 12 to begin with, 12 minus 6 is equal to?
6.
Right, so he will have only 6 left. He will now have 6 pigs. He also receives how many chickens?
6.
6 plus 6.
12.
He now has how many chickens?
12.
Right, so during the exchange, he takes away 6 of his pigs. So that's 12 minus 6, which is equal to 6. And he will have an increase of 6 chickens. So he will have what? 6 plus 6. And that will be equal to
12.
12. Let us now revise the pie chart in order to show the new numbers and the changes, the size of the sector. So let us now revise the pie chart in order to show the new numbers and the changes in the sizes of the sectors. Alright, like that. But why can't we just do that, Jerry? Well, we cannot just do that. We have to understand that if he has another 6 chickens, that will be how many chickens, Jerry? 6 plus 6 will be equal to?
12.
12. Because of that, the 12 chickens that we have, we know that when we have the number 12, it is what fraction of the entire pie?
Half.
It is half, right? So 12 represents half of the entire pie. That's correct?
Yes.
And 6 represents what fraction?
Quarter.
A quarter. Therefore, when he has 12 chickens, the chickens will represent what? Now represent half of the pie. Is that right?
Yes.
So 12 will still be half of the pie. And the 6 pigs will be what fraction of the pie?
Quarter.
Right, so we change it around. So the chickens will now have half of the pie, and the pigs will now have a quarter. Not only that, because that's not so important. What is even more important is the number of each that we need to figure out. So let us now revise the pie chart, and we have done that already. So what we will do now is complete the table by writing the name of the animal that correctly matches the number of animals. How many goats do we have?
3.
How many do we have in the pie?
3.
We are correct. The row of the table that contains goats is complete. There's nothing to do. And it is correct. 3. 3 represents 3 what?
Cows.
Right, so we match the 3 here with the 3 that we have there, and the 3 that we have up here left is represented by?
3 cows.
Right, so what do we put here?
Cows.
Right, the number of cows in the table matches the number in the pie chart. So we have no doubt that we have 3 cows. Let us look at the 12. 12 is represented by what animal?
Chickens.
Right. But we are not going to the 12 as yet. We are going to the 6 first. And the 6 is represented by 6 what?
Pigs.
Right. So let's get in the pigs. The numbers match. 6 with 6. So we know that the 6 represents 6 what?
Pigs.
Right. 6 pigs. The only one that is left is?
Chickens.
Right. And how many, what number do we have here?
12.
And how many chickens we have there?
12.
So may we put chickens right here?
Yes.
Only the chickens are left, and we may just put them in. But let us ensure that they match. Do they match? 12 with 12.
Yes.
They match. So we have 12 representing the number of chickens. So we have 3 cows, 12 chickens, 3 goats, 6 pigs after the exchange. A farmer has 24 animals. There are 3 what? Goats. Our original pie chart may be compared to a circle that is divided into how many equal parts?
4.
4 equal parts. That's what we are doing. I'm just taking a look at the pie chart again so we can come to a conclusion, or we can be more conclusive that the numbers that we use were actually correct. I think that what we have done so far is enough to convince anyone. But we are going at length to make sure that there is no stone left unturned. So we are saying that we can take a look at it as if it is divided into how many equal parts?
4.
4 equal parts. 2 of those quarters are allotted to the pigs. Right. So 2 quarters allotted to the pigs. That will give us half of the pie. That's right?
Yes.
It means that half of the pie belongs to the pigs. The farmer has how many animals?
24.
Right. So 24 divided by 2, which is half of the total, will give us 12. We may look at the chickens in any of 2 ways. 1. Chickens have quarter of the pie, which is 24 divided by 4, which is equal to 6. So that's one way. A quarter of the pie is allotted to chickens. So we may say 24 divided by 4, and that is equal to 6. Or the second way is that chickens have a half of portion that the pigs have. So chickens have a half of the portion that the pigs have. Notice that this is a half, right?
Yes.
And if we divide it into 2, we get 2 quarters. Therefore, whatever we have here is a half of this.
Yes.
Right. So we may say that the number of chickens is half of this. So 12, which is, this is 12, right?
Yes.
12 divided by 2 is equal to 6. Chickens have a quarter of the pie, which is 6. The remaining quarter, which is 6, is shared equally for cows and goats. Let me ask you a question, Jerry. How do we know that this is represented by 6 animals? Because what? Because it is a quarter of the pie. Do we have any quarter there? Any other quarter apart from that one?
No. Yes.
And how many animals are there in that quarter?
6.
Right, because 6 animals are in that quarter. It means that if we have a quarter here, how many animals should be in this quarter then?
6.
Right, because it is a quarter. So we have 6 in this quarter that we have right here. And this is another quarter. So we know that the total number of animals here must be equal to 6. Right. So we have 6 animals in that quarter, but the quarter is divided into 2 equal parts. So if we have 6, we divide that by 2, what do we get?
3.
Right, we get 3. So 3 will belong to each one of those. This problem is saying that we should pretend as if we have a ball of strings 6 meters long. So it is 6 meters long. And we need to put this string along the edges of the rectangular table that we have right there in the picture. You are to show what you would do to find if the string is enough. What will we do to find out if the string is enough? The tabletop that we have there is rectangular in shape, and we have the dimensions of the tabletop, which is 70 centimeters by how many centimeters, Jerry?
30.
70 by 30, and we need to put the string along the edges of that tabletop. But we know the dimension of the tabletop and we know the length of the string. Do we have enough string?
No. Yes, we have enough string.
How do we know that we have enough string? Well, we will show that we have enough string by first finding the distance all the way around here. And if the length of the string is more than the distance around the top of the table, then we are sure that we have enough strings. If the string is not longer than the distance around the top of the table, then we are sure that we do not have enough strings. The tabletop is rectangular. Opposite sides of a rectangle are parallel and they are also equal. So because they are parallel and they are equal, what is the length of this side, Jerry?
70.
70 dumplings?
70 centimeters.
Okay. And this one?
30 centimeters.
Okay. Right, so there we have it. If we find the perimeter of the top of the table and it is smaller than the length of the string, then he has enough string. Let us find the perimeter of the tabletop. So we will find the distance around the top of the table, which is the perimeter. And if the string is longer than that, then we know that we have enough strings. As a matter of fact, we will have more than enough string if it is longer. The perimeter P is the distance around. Let us find the distance around the top of the table. So we start right there, 70 centimeters, and then what will be the next dimension?
30 plus 30
And then we,
plus 70
and then we,
plus 30.
right. And that is equal to 200 centimeters, Jerry. Surely he has enough strings because 200 centimeters equal to 2 meters, while he has as much as 6 meters. So he has 6 meters, which is 600 centimeters of string. Therefore, he has enough strings. Okay?
Yes.
Okay.
1 meter.
100 centimeters are equal to,
1 meter.
convert 200 centimeters to meter. How do we do that? We have 200 centimeters. What do we put on this side?
2 meters.
Right. We are just causing the table to be consistent. It is clear that when we are converting from the centimeter side to the meter side, we need to reduce the number by 2 places of decimal, which is the same as dividing by 100. What do we do?
Dividing by
100. So when we are converting from this side to this side, notice what we have there. 100. What do we have here?
1 meter.
Right. Therefore, the number that we have here, which is 1, was reduced by 2 places of decimal. So if we are consistent to get what we have for 200 centimeters, we will also reduce by 2 places of decimal, and we will get 2 meters. Convert 6 meters to centimeters.
600.
Jerry is saying that it is
600 centimeters.
600 centimeters. When we are converting from the meter side to the centimeter side, we need to increase the number by 2 places of decimal, which is the same as multiplying by 100. There we go. It is easy to convert from one unit to the other as long as we know how many of one makes the other. We may then think of the conversion as a transference from one side of a table to the other. Using the first row as a guide, all that we need to do is maintain the consistency in the table. So that's what we need to do. Maintain the consistency in the table. If we can maintain the consistency, then we are sure that we are converting correctly. 100, 1. 200, 2. 600,
6.
500.
5.
That's how it will be. The perimeter was found to be 200 centimeters. The length of the string was given as
6 meters.
right, 6 meters. So there we have them. If we convert the 200 centimeters, what will we have on this side?
2 meters.
So we know the conversion factor already, which is that 100 centimeters equal 1 meter. We may convert any way that we want. We may convert the centimeter to meter or the meter to centimeter. Since we have done it both ways already, let us just write the numbers down again. So we have done it already. So we may write the numbers down again. Right. After doing whichever conversion you find convenient, the comparison will be the same, whether you compare in centimeter or you compare in meters, right? So if we are looking at the centimeter forms, we have the length of the string to be 600 centimeters. That is still longer than the
200 centimeters.
which represents the perimeter of the tabletop. And if we compare in meters, we have how many meters here?
6 meters.
And how many meters here?
2 meters.
Right. So, anyhow we compare, we will see that the string is longer than the perimeter of the tabletop. Irrespective of the one that you choose, you will discover that the length of the string is greater than the perimeter of the tabletop. He therefore has enough strings. The tabletop is rectangular. As usual, for a rectangle, we will call the long side its length, and the shorter side we call
Width.
and somebody will call it the breadth to say that it is broad. That's how broad it is. They call it the breadth. So we have length and breadth, or we have length and width. Do not forget, opposite sides of a rectangle are equal. Let us find its perimeter P, which is the distance around the top of the table. So P is equal to length plus width, then plus length again plus width. We have 2 occurrences of L and 2 occurrences of W. The perimeter may therefore be written as twice L plus twice W. So the perimeter may be 2L plus 2W. L plus W, L plus W. We have 2 W's and we have 2 L's. 2 L's plus 2 W's. Later on in mathematics, you will learn to factorize and see that twice length plus width W may also be written as twice the sum of length and width. Although you have not gone through those algebraic processes as yet, it is still logical to you. So we have what? 2L plus 2W. 2 times the sum of the length and the width. So 2 times the sum of L and the W. What are we about to do on this slide? To show that irrespective of how we write the formula, that the result will be the same. So remember the perimeter in which we added the edges of the tabletop individually. P is equal to that, and do not forget, that's something that we had on a previous slide where we added the length of the values all the way around. Let us show that we will get the same result if we use the perimeter is equal to 2 times the length plus 2 times the W, or the width. So P is equal to 2L plus 2W. That's right?
Yes.
What is the value of L?
70.
And the value of W is?
30.
So 2 times 70 plus 2 times 30. 2 sevens.
14.
So-
140.
So that's 140 and the other one is 60. 140 plus 60, what's that equal to?
200.
Are you sure that it is not 100, Jerry?
No, it's 200
Okay.
centimeters.
Show that 2 times the sum of L and W will also work. P is equal to what? 2 times the sum of L and W. What is L?
70.
And W is?
30.
Add them. 70 plus 30.
100.
100 times 2.
200.
Right. Whenever we have numbers occurring like this, in which we have one preceding a pair of brackets in which we have the other one enclosed without any sign, multiplication, addition, subtraction, the sign that we are sure that we are assuming has to be multiplication. Right? So whether we added all the way around or we use 2 times length plus 2 times W, or we use 2 times the sum of L and W, the result will be the same. If the formulae are correct, then they should all yield the correct result. Not only correct, but the same. We are therefore sure that they are all correct.